Stand. Stand.
There you go. Yep, that's me. As always, chat, if you feel that the music is either too loud or too low, so let me know. I think that 14 is the number. So I usually use it as 14 or put it as 14. Just let me know if it's not good, okay? Cool. Welcome to my second stream, and I have two today. So I have one right now. I have a break of another person's stream. I think it's Kari's. Yeah, we have Kari then, and after Kari, I have another stream, which is part 2. Okay. So yeah, cool. Nice to have you here. As always, we start with chicken. Couple of catches. Wait a minute. That should be it. Go. Oh, good. Nice. So, let me start sharing the screen. And should I share the entire screen? Maybe. Yeah, I think that's good. Okay. Cool. By the way, first things first is, I don't know if you want to follow the code. You can find the codes from yesterday and all of the codes from today here. Okay, and the PDF that I used yesterday, which is here. Oh, by the way, banner out. There you go. Everything about neural networks that we talked about yesterday, it's here. Okay, so you can find it in my GitHub. Okay, cool. So this is the, yeah, I'm gonna get rid of this just because of this. Okay, cool, awesome. So slideshow, and let's start. Hello, my name is Charbel. People call me Bully. Yeah, I'm a robotics and telecommunications engineer. I work at MLH as a program coordinator in the fellowship. I'm also a streamer, as you can see. I also work, I'm a robotics engineer at a startup in Australia. So we work with computer vision and drones, stuff like that. So it's really awesome. I love it. And you love it when it works. When it doesn't work, it's like frustrating, but it's part of the deal. Okay. Cool. Awesome. And yeah, if anything, just let me know on the chat. Okay. If you have any questions, ask. Okay. I just pause the stream and answer the questions. Okay. Cool. So what are we going to do? Like, what is this 2-part stream about? We are going to build a very, very smart IoT system. Okay. We're going to use MQTT for communications. We're going to use MediaPipe to see our hands and track the movements of our hands. We are going to use electronics. So everything is simulated. Okay, so no need for an ESP32, which is what we're going to use. Everything is in the computer. Okay, you don't need to buy anything. You just follow the code. Okay, cool. Yeah, that's pretty much it. So this first part, I'm going to focus specifically on the AI part, the one that's going to track our hand and send the information. And part 2, which is in 4 hours, I'm going to focus on the electronics and the communication. Okay. If I have more time today, I'll focus on, or if I have more time in this first part, I'll start focusing on the MQTT part, which is the communication part. Okay, cool. So you can see here, building a very, very smart IoT system, part 1. What is this about? Okay, so first of all, let's understand what we're going to work with. Okay, yesterday I explained in depth how a neural network works. Okay, let's just kind of run over it again and see if we learn something. Okay, cool. So a neural network is a system of neural networks of neurons. Sorry, that in computer systems we are trying to mimic brains. Okay, so we pass, let's say, signals through those neurons. They activate, and depending on the activation pattern, we can understand stuff. Okay, for example, we can understand what an image is. If an image is a dog or a cat, we can understand if like we can type something and it returns an answer. Okay, all of those are different types of neural networks following the same basis. Okay, we have input layers, we have hidden layers, and we have output layers. The input layer receives the data, is the one that parses the entire thing that we give it, like text, images, or basically numbers. Hidden layers compress what the input layer gives them using mathematical formulas. We learn, or they learn, patterns, features, and relationships. Neurons activate or deactivate based on those patterns. Okay, and the output layer produces a prediction. Okay, it's the one that decides, hey, based on what the others have been saying, I think your image is a pizza. Yep. That's what they do. Okay. In short, neural networks learn by example. More data, the smarter they get. Okay. And you can see here, this is a neural network. Okay. We have the inputs here. We have some hidden layers here. Okay. And we have something called the activation functions. Activation functions are the one that are going to determine if the neuron gets activated or not, or how activated is the neuron getting. Okay. For it to understand or to train, you can see if we go from the input to the output, that direction is called forward or feed forward neural network. Okay, it just goes forward. To learn, it has to do back propagation, which is go back, get the errors of the output, and tweak the weights, which are the numbers of each of these lines, okay, for it to learn. Okay, that's what we did yesterday. We won't do it today, but that's the basics of it. Okay, we have some types of neural networks. We have feed forward, we have convolutional, and we have recurrent. Okay, feed forward are the simplest type. You just give the information and they output something. They don't learn anything. Okay, you can see feed forward neural networks as in neural networks that are already trained. It just goes one direction. Okay, cool. CNNs or convolutional neural networks are the ones for images. If you want to use or classify an image, you use a CNN, and they detect patterns like edges, shapes, and objects. Okay, and we have another type, which is recurrent neural networks, which are designed for sequences like text, speech, basically stuff that have to do with time. Okay, they remember previous inputs. Okay, so we have many more types of neural networks, but let's say that just these three. Okay, this is a feed forward one. As we saw, we have the inputs, the hidden layer, and the output. Okay, we can calculate the error here, and then we go back and train. Okay, this is a CNN. Okay, now this is the easy way to look at CNNs. Okay, you get an image. If you remember yesterday, we used this exact dataset, which is the MNIST dataset. But we didn't use a CNN. It was just a neural network, a simple one. Okay. CNNs pool, convolute, and flatten the image. Okay. Those are mathematical things that they do. Pooling is getting the, let's say that they blur the image. Okay. Convolution is they highlight some either shades or edges. Okay. And flatten means instead of having a matrix, they vectorize everything so that the end or the output layer understands. Okay, that's a CNN. Now, a recurrent neural network, in a simple way to see it, is we have the input layer, we have a hidden layers here, we have the output layer, but then we kind of feed it again back to the hidden layer so we remember. Okay, for videos, for text, for everything that has to do with time, we used RNNs. Okay, the one that we're going to use today is a CNN. Okay, we're not going to dive into the CNN by itself. We're just going to call it from MediaPipe. Okay, which I'll explain what MediaPipe is in a second. Now, let's go to MediaPipe first. Okay, let's do this. Okay, so MediaPipe is a Python library that Google AI for developers developed. Okay, you can use it for free. Okay, and it has a lot of things. Okay, you can do lots of things. You can gesture, like you have gesture recognition here. You have interactive segmentation here. It's really, really, really good. The one that we're going to use is hand landmark detection. Okay, this one over here, you might ask, hey, why don't we use the gesture recognition just so we design our own gestures? Okay, cool. So you can see that we have a bunch of things here, but the most important ones are these. Okay, let's go back to our slideshow here. There we go. Cool. So each part of our hand will be numbered. Okay, so for example, 0 will be here, 1, 2, 3, and 4. Okay, You can see 5, 6, 7, and 8, and so on with the rest of your articulations, okay, or joints. You can see that we have them numbered, okay. We're going to use these numbers to track our hand and to say, hey, we're giving a thumbs up, or it's a 2, or I think one of the commands is like just a pinky. We can use it as we want, okay. The idea is we're going to control a simulated environment, 2 lights and 1 door, okay. So bedroom lights, and garage doors, to open and close or turn on and turn off from one point to another using MQTT and our hand. Okay, sound good? That's the project. Okay, cool. So this is what we're going to do. Again, we use our hand to track what we're going to do and do some electronics. This is not the electronics that we're going to do. It's just an image. Do some electronics, connect my computer to Walkway, which is the page that we're going to use for simulating the ESP32. And then we have an IoT system controlled by our hand. Yep, okay, cool. Again, just let me know if you have questions, okay? Cool, now let's get started. Should I open? I should open Visual Studio Code. I also should get my cheat sheet, because if I don't see my cheat sheet, well, I don't remember all of my codes. So wait a minute. My iPad should do the trick right now. Let's see. Yeah. Okay. GitHub. By the way, again, everything is on my GitHub. So if you want to follow my code, it's all there. Okay. Cool. So let me just. Oh, okay. This is not what I wanted to. No, it's this one right here. Okay. I have everything here. I just tested it before. I probably should do another one here. Let's do IoT stream. Okay, cool. And here, can I kind of move there? I should use this maybe. Let's see. While it loads, let me just give me a second. Let me just get the code real quick. My profile, my repos. Cool. How quick there is CD desktop, and then I have streams. What was the name? CD IoT, and then code. Cool. So now that we're here, okay. What is your GitHub, by the way? Oh. It's here. There you go. Cool. Awesome. So nice. Let's open Visual Studio Code. Okay. Let's see. Where are my codes? Code. Is it APIs? No, it should be. Don't I have the AI one? What? Great, I have network errors. Wait a minute. Is everything okay? Should be all okay. Am I okay? Should be all good. Yes. Well, I don't know. Then I'll just pick GitHub from here. My iPad is just not getting it. Let's see. GitHub, come on. I'll just open it here. I'm sorry. There you go. Now, where are you all? Cool. Yeah, that's good. Let's see if I can open it again. If not, then I'll just use my computer. It's fine. Yep. Nope. For some reason, it's saying network error. Oh, there it is. AI should be part 1. Nope. Yes, but not this one. Should be IoT control. Yeah, there you go. Okay, got it. Cool. So, opening Visual Studio Code now. Let's start with something that we'll call camera dot py. Okay, by the way, first step, go to your terminal. Okay, we're going to use MediaPipe. Okay, sadly, MediaPipe doesn't work with Python over 3.10. Okay, so you don't need to downgrade Python. You need to only download Python 3.10. There you go. If you go to download Python, find 3.10 and download it. Okay, don't add anything to your path, or I don't know how it works with Mac, but don't activate this Python 3.10. Okay, what we're going to do is download it and then do this. Okay, because you have it downloaded, then this should work. Okay, we're creating a virtual environment with 3.10. It doesn't mean that you're downgrading. It means that from the two versions that you have in your computer, you're using 3.10. Okay, so I'll do that. It shouldn't output an error. So I should do pi dash 3.10, and then I'll do dash m vnv env. Okay, I just like calling my virtual environments env. You can call it as you want. Okay, shouldn't output any error now. Okay, yeah, no errors. Okay, if you're in Mac or Linux, you should use Python 3. I guess it's 3.10. This should be the same. Dash m vnv, like this. Okay, this will work with Windows. Yeah. For Windows, if you want to activate your environment, you do the name of your environment. In my case, it's env. It's in scripts, activate. Okay. It should activate now. You can see it here. It says env. Okay. Ignore the base. I'll actually do conda deactivate. It's conda. Okay, but there we go. So you can see here the green env means my env is activated. Okay. If you're in Mac or Linux, what you have to do to activate it, you have to use source env if it's called env, bin, and then slash activate, like this. Okay, that's how you have to do it. You have to use the source. Okay, cool. If you have any questions, just let me know in chat. Okay, I'll assume everything's working. Again, remember you have to use Python 3.10, okay, which is here. Okay, you can go. I can share this if you want. Cool. Okay. So having this, we have 3.10. We can do pip install, should be MediaPipe, like this. It's collecting MediaPipe. It takes a while just because it's a very big library. Okay, my hands are like, it's really cold now, or at least for me. Okay, and my hands are just like numb. So if you see me typing weirdly, it's because my hands are not warm at all. Okay, yeah, whatever. Okay, this is okay as long as we're using MediaPipe for 3.10, so it's fine. Cool. So now that we downloaded MediaPipe, now we can use it. Okay, now we have to pip install. We have to use OpenCV2, so it's Python dash OpenCV, I think, or it's OpenCV dash Python, like this. Yeah, there you go. Okay, cool. So download OpenCV Python 2. Okay, nice. Now in a camera.py, okay, just for sake of the argument, and we're going to kind of work with this later, just import something from IOT, import IoT connection. Okay, this doesn't exist. Okay, at least not now. So just import it, and if we have time in this stream, we'll do it. If not, we'll just write IoT control in the next stream. Okay. Given late, is there anything I can look to follow up the steps to start? Oh yeah, where's your starting? Just download Python 3.10. Create your virtual environment with this over here, and then just follow the Python. Okay. Cool. Nice. Now let's just there we go. Cool. So we also need import CV2 and import media pipe as MP. Why is it not recognized? Is it activated? Wait a minute. I don't think it's activated. Wait a minute. Let's see. Python base. No, it's not here. If not, then I'll just leave it like this. But if not, if I can find the, why is it using? It's using my Python version 3. Oh, there we go. This one. That's it. Okay. Cool. So if you are in Visual Studio, just make sure that you're using the env that you created. Okay. So if you see a squiggly line, it means Visual Studio is not getting what you're doing. In our case, it was weird because we downloaded MediaPipe and CD, OpenTV, and it didn't recognize it, so it was incorrectly routed. Okay, cool. So now we need a class. Okay, if you're not familiar with object-oriented programming with Python, just let me know. Okay, I'll kind of assume you know stuff. I'll explain some other stuff. Okay, but if you don't know something, just let me know. Okay, I'll zoom in a bit more. Is that okay? Is this better? If you need more zoom, just let me know. Okay, so we do class. It's called hand tracker. Okay. If you're declaring a class in Python, it's like this. If you want to inherit stuff from another class, from a parent class, you'll put the name of the class inside of this brackets, inside of this parentheses. Okay. The name of the other class is called IoT connection. Okay. We're going to write IoT connection later. Okay. Let's just assume we have it. Okay. Cool. Now, let's use init. Or dunder init, which is double underscores init, allows you to create. I always forget the name. It's not a builder. It's a constructor. Okay. It's a constructor function that gets called whenever you call the class. Okay. So, for example, if you want to instantiate variables at the very beginning, you can do this with this. Okay. Cool. Now, first argument always itself. Okay. Self is a pointer to itself in memory. Okay. So if you have 10 classes of the same class, or like 10 objects of the same class, Python knows which one is routed where. Okay, cool. So we have mode equals false. We have max hands equals 2. Detection confidence equals 0.5. I'll explain all of this in a second. Model complexity equals 1. And track confidence equals 0.5. Okay, cool. Now we have a mode. I think I'll read more about mode in a second. We have max 2 hands. Okay, so it doesn't bug whenever we show 2 hands. Detection confidence. It's not that it's 50% confident that it's your hand. It's that it'll use 50% of the confidence of the prediction. Okay, not that it's kind of 50-50. It means that it's going to use this confidence. Okay, the complexity should be 1, and the track confidence should be 0.5. Okay, it works. I tested it before, so let's just use these. Okay, you can experiment later. Okay, cool. Now we have to do something before, like at the very beginning, which is we have to call parents init. Okay, so this one will have its own init. For it to be called, we have to use something called super. Okay, super routes this init to the parent init and calls it. Okay, so it's super dot dunder init. Okay, cool. So far so good. We're calling the init function of IoT connection, which will write just after this one. Okay, cool. So variables. We have self.mode equals mode, self.max hands equals max hands, self.detection confidence equals detection confidence. Okay, what we're doing is routing it to object variables. Okay, so from input variables to object variables that the whole class can understand. Okay, cool. Now, self.model complexity equals model complexity. If you kind of ask yourself, like, why don't I have predictive text? I hate it. It's just sometimes I just click tab or enter just because I want to either change lines or like add a tab, and it autocompletes and it frustrates me. So if you don't see autocomplete, I don't like autocomplete. Okay. Cool. Self.track confidence equals track confidence. Self.mp hands equals mp.solutions hands. Okay. Self.hands equals self.mp. I'll explain this in a sec. Hands that hand, and we're declaring the hand object. Okay, this hand is going to have all of these. Okay, so we can have self.mode, we can have self.max hands, self.model complexity, detection confidence, and self.track confidence. Okay, cool. Now, next one is self.media pipe draw, because we want to draw our hands equals mp the solutions that drawing utils. This will help us to draw our hands. Okay, drawing utils. Okay, and then self.command equals none. Okay, and self.priv equals none too. Okay, now what does this mean? Okay, this is the helper to draw our hands. The command in the previous command, the command is going to be the one that stores the actual command, or like the command that we're giving it. Okay, so for example, open door, close door, open should be open door, close door, turn light on. I think it's to turn light off, bedroom light on, bedroom light off. I think that's the pattern. So if we want to send only the commands that haven't been sent before, or like we're not repeating commands, we have to have a prep command. So it kind of sees, hey, are we trying to open the door? Even if the door is open, then we won't send anything. If the door is closed and we can open it, so send the command open. Okay. Cool. Now, every method, or every method is your function that's inside of a class. Every method that starts in Python with underscore, it's like the name by itself doesn't do anything to the class, but we know it's a convention that it's an internal method. something that's not accessed by outside. Okay, cool. So hand finder, like it works the same if you write it like this. Okay, just for us to learn something new, underscore before means it's internal, not external. Okay, cool. We have to do self. Okay, image and joy equals true. Cool. So the hand finder will get the image, decode the image, and then process the image with hands, and this neural network will track the hands. Okay, let's do that. Okay, so image RGB equals cv2.cvt color, image cv2.color VGR to RGB. Okay, what we're doing is getting an image and changing the color from BRG, it should be BGR, my bad, BGR to RGB. Okay, cool. Now, next thing is self that results equals self that hands that process image RGB. There we go. So we have our hands, which is the model, processing the image for it to give us the results. Okay. Now, if we have a result, because if we don't have our hands, if we're like this, then we cannot draw anything, right? There is no hand detection. So we have to check, hey, if self results that multi-hand, it means, do you see a hand for each landmark in self the results that multi and landmark, it's landmarks with S. Then if we want to draw, we do self.mp draw, which is our helper to draw. Dot draw landmarks, okay, like this. And then we do where in image, what do we want to draw? Our landmark. Where in self.mp hands, that hand, like this. Okay, so what we're doing again is getting the image into RGB format. That's what hands expects. We process the image, meaning we are predicting where a hand is. Okay, predicting is, hey, I see your hand here, I draw a box, and here's the hand. Okay. If we have a hand, then we draw the landmarks per landmark. Remember, the landmarks are these here. These ones. Okay, so this is a landmark. We have 20 landmarks. Okay, cool. Now, return image. Okay, we're going to use this image that's been drawn on before later. Okay, cool. Now, position finder is going to be a function that will give us where the landmark is and enumerate the landmarks. Okay, so we need the self. Should I drink? Maybe later. Image hand number equals 0. It's the first hand. Okay, and draw equals 2. Okay, cool. There we go. So we need something called landmark list. That's, we don't know where the landmarks are yet. We know we have some, but we don't know where they are. Okay, that's what we're going to answer. So if self dot results dot multi hand landmarks. So if we have a hand, then by the way, you'll see, hey, where is results? Results is not in here. Oh, because we have the self and we declare it here. Then this is accessible to all of the methods inside of the class. Okay, there we go. And that's it. And then hand equals self that results dot multi hand landmarks, which hand number, which is 0. Okay, first hand. Now, for each ID of the landmark and landmark, enumerate hand dot landmark. Okay. Why a colon here? I'm not sure. Then we have height and width equals image dot shape. And now cx, and I'll explain this in a second, cy equals int of landmark in x times the width and int landmark dot y times height. Okay, and self dot lm list dot append the ID of the landmark, coordinate x, coordinate y. Okay. What are we doing? Let's recap. We are trying to get the position of the landmark. We know we have landmarks here. We get the results. If we have a hand, then we can have one hand or two hands. We'll get the first one, and then we say, hey, for each ID and landmark of every landmark that we have, which without the 0, we want the height and the width of the image. So we can map them using this landmark in x times width, landmark in y times the height. We're going to add this or append it to the list. That's going to help us see what are we doing, like relationally based on my this landmark number 0, which is here. Where is the thumb, or where is the index? Yeah, or where is the pinky? Okay, yep. So far so good. Cool. Now, if ID equals 0 and draw, then cv2 the circle image cx and cy. I'll explain in a second. Wait a minute. 10. The color should be 255. 0, 255 with comma there. TV2 like this. Okay, now what are we doing here? ID 0. Remember which landmark is ID 0? It's the palm one. Okay, I want to kind of highlight this one so we know it's not a finger and we can map the rest of them, mapping or based on 0. Okay, that's why I'm coloring it RGB, so it's should be like purplish. Okay, it's a filled circle of a 10 radius in CX and CY coordinates where on the image. Okay, cool. Now that's what position finder does. Okay, we don't return anything, we just save it here. Okay, cool. So now we have to have a function that tells us, hey, your finger is down or your finger is up. Okay, let's do def underscore finger down. And I think I'm going to drink something, because if not, I won't have voice. Fingers goes like this. Okay, wait a minute. There we go. Okay, funny thing. Okay, I bought this energy drink. Okay, because I know I have two streams. I put it on top of my car. As I was opening my car, it kind of slipped and it fell right over my toe, and it hurts. Okay, I hope it's not broken. It shouldn't be, but yeah, it was funny. I was like, I felt really weird. It was like, I don't know why it felt, but yeah. Okay, so let me just. I think it just got. I shaked it a little bit, so let's see if it doesn't explode. It's good. I think it's good. Wait a minute. Okay, it's good. Didn't explode. Oh, yeah, it's good. Okay, cool. So, nice. So, where were we? Oh, no way. Tammy's here. Hey, Tammy, how are you? Tammy never misses a stream, okay? Thank you, Tammy, for every single time being with me. Cool. So, let's see if we can find or we can make or we can decide if a finger is down or up. Okay. Now, I'll walk you through the logic behind it. Okay. Each landmark represents a joint. The landmark that we're more interested in is for 8, 12, 16, and 20. Okay. Those are the tips of your fingers. Okay. So if we have 8, 12, 16, or 20 under a certain or close to landmark number 0, it means it's down. The problem with that is that your thumb is not all the way up. It's kind of to the left a little bit. So we have to take into account CY, or the Y coordinate, and the X coordinate. Okay, so we don't misread if the thumb's up or down. Okay, to do that, we're going to get height equals a list. Okay, for finger in fingers, because we can add the finger number here, and it should be smart enough to give us true or false if the finger is down or up. Okay, so if the finger is 4, what does that mean? It means it's the thumb. Okay, so for the thumb, height that append should be heights. Yeah, heights that append. The true. Okay, if and only if self the landmark list in 8, and I'll explain the logic of this in a sec. 2 minus self the LM list in 0, 2 is bigger than or equal to 150. Okay, what does this mean? We have finger number 4. Okay, finger number 4 is this one. Okay, if the landmark lists, wait a minute, no, it's not. Yeah, that's what I thought. It's not it. It's finger. Yeah, that's what I thought. Okay, now if we have the thumb, it's going to be true if the landmark list in finger, which is 4, into which is its y value, okay, its height, minus the landmark in 0, which is this one, its height, it's bigger than or equal to 150. Okay, so if what am I doing? Wait a minute. No, I just totally got it wrong. Wait a minute. Okay, scratch everything that I said. Let's do it again. True if the absolute value of self the landmark list. I just saw another function. My bad. In finger, and same thing in 2 minus self the landmark list in 0, 2 less than, this number is less than 100. else, false. Okay, now it makes sense. Okay, I was reading it out loud. I was like, what? Oh, okay, now it makes sense. So we append true if the number of the finger, which is 4, what we saw, this minus this is less than 100. Okay, that number works. I kind of just measured it with my hand. If it's less than 100, we can kind of assume it's closed. If not, then it's opened, meaning false. Okay. Now, else. Okay, if it's not the thumb, we should do the same thing, but instead of 100, should be 90. Okay, because it's not the same having the thumb like this or having the, you see, it kind of goes down a little bit more. Okay, go. So the same thing. Okay, we're using the 0th landmark, the Y coordinate, to see if the hand is down or like the finger is down or up. Okay, cool. Now we should return heights here. Okay, cool. So far so good, all good. If questions, let me know in the chat. Okay. So now, yep, we're getting into the middle of this. Okay, so now we need to create gestures. Okay, we need to see or say, hey, thumbs up, or like this 2 or 1 or pinky or closed. I think we have one like thumbs up. That's going to be one command. Okay. I didn't use the gesture command just so we can kind of dive into more media pipe with landmarks. Okay, it's more fun. Okay, I think it gives you more freedom, so you can use or you can create the patterns that you want. Okay, so we do def gesture command like this. Okay, so if we have, what does this mean? It means, hey, are we looking at a hand? This will be activated here if there is a landmark list. If we don't have a landmark list, then we don't have hands. As easy as that. Okay. So if we have hands, basically, let's start by saying turn bedroom lights on. Okay. How? We say, hey, if for this is going to be index only. Okay, so index up like this should be bedroom light on. Okay, so if the absolute value of self.landmark list in 8 and 2, which is the Y value of it, minus self.landmark list in 0, 2 is bigger than or equal to 150. This means, hey, if our index finger is up, then I want to check, are the rest of the fingers down? So let's do h equals self.underscore finger down, and the fingers are going to be fingers number 12, 16, 20, and 4. We're just interested in index up. Okay, so we want to make sure that 12, 16, 20, and 4 are down. Okay, so we said 12, 16, 4, and 8. Was it? Oh no, 20. My bad. Not 8, 20. So let's check if those fingers are down. Okay, the way we do it, we'll have a list of trues and false. Okay, we will check, hey, if the length of the set of h double equals 1 and h in 0 is true, what does this mean? Give me a second. Print bedroom light on. like this. Okay, what does this mean? Now, let's just draw it here so y'all can see it. So we have a list that says true, true, false, true. Maybe that's a possibility, okay? This is the list. Now, a set is like a tuple. It's with parentheses, but it doesn't repeat. Like it doesn't have, or it cannot have repeating values in it. So a set of this would be true, false. Okay, so here we check, hey, do we have either all trues or all false? Okay, in the scenario that we're looking for, it's all trues, making this false disappear, making the length of the set 1. And we check, hey, is the first value of our list true? If it is, then we know the only value of this set is true. Hence, we know that everything is down except index. So far, so good. Okay. Now, if you say, hey, why cannot we just iterate through the set? You cannot. Okay, you cannot subscript sets. Okay, cool. Now that's the logic behind it. Okay, now if, or let's actually turn bedroom light off, and this should be all fingers down, like this. Okay, so we do if the same thing, the absolute value of, or actually we can check if everything is down using our function. Okay, so we say if the length of the set of self dot finger down, the number of fingers that we want to see if they are down are all of the, like the top. So it's fingers equals, should be 4, 8, 12, 16, and 20. Okay, 4, 8, 12, 16, and 20. Okay, I like giving them some space because it's more readable. Okay, if this is like the same logic, okay, if we have a set of length 1, it means we have one value, either true or false. Either all of them are up or all of them are down. Okay, and self dot underscore finger down, like same thing here. Let's just copy paste the whole thing, this thing. Like this. If all of those fingers in 0 is equal to true. Okay, it means, do I have consistent fingers up or down? And the only option that I can, or that I want, is for them to all be true. Okay, if so, then we can assume that the bedroom light is off. Okay, cool. So far, so good. I'll probably zoom out a little bit just so you can see this part of the code. Cool. Okay, so now we will turn the garage light on and off too. Okay, so I'll zoom in a bit. Turn garage light on. Okay, so we do if the absolute value of self.landmark list in 12.2, this means this finger right here, the middle finger, and this should be 2 with index and middle. Okay, like this. So if the absolute value of this coordinate minus this coordinate right here, which is self.landmark list, in 0, which is our palm landmark, if this value is greater than 200, because it's the middle finger, okay, it's the highest one compared to our bottom part of the hand, then H equals self the finger down, and we're going to check for, remember, we're trying to make a 2 like this. So we want 8 and 12 to be up. So we want 16, 20, and 4 to be down. Okay. Should be fingers equals 16, 20, and 4. Okay. If those are down, we do the same thing for if the length of the set of our heights double equals 1 and H in 0 double equals true. Then we know we have a 2 like this. Then print garage light on like this. Okay, cool. Now let's turn that off. Okay, to turn that off, only pinky like this. Okay, so all fingers down except pinky. So turn bedroom light off, only pinky up like this. Okay, the absolute value of self the, we get the landmark of 20, which is a pinky. Okay, so self the landmark list in 20. Again, we get the y value of it. Yeah, it's here. Number 2 minus self the landmark list in 0 and 2. Greater than or equal to 135. Okay, these numbers, again, I tested them before. They work with my hand. I hope it works with yours. Kind of should be. But yeah, let's see. Then we get the heights again. Self the underscore finger down. We're going to check if our fingers that are down are, we want only pinky up, so we need 16, 12, 8, and 4 to be down. Okay, so 16, 4, 12, and 8. 16, 4, 12, and 8 to be down. So if length of set of H double equals 1 and H in 0 double equals true, then we have only pinky. So we print garage door, actually garage light off like this. Sound good? All good so far? I hope so. I hope so. Okay, cool. Now last 2 commands. Okay, doors from the bedroom, I'm sorry, light of the bedroom, we can turn it off and on. Garage light on and off. Now we need garage door. Okay, it's the same thing right here. It's going to be different in our Arduino. Okay, thank you so much, Tammy. With the less comprehensions, I still write very long lines of code. Oh no, it's fine. Everyone has its own style, but thank you, Tammy. I appreciate the comment. Cool. So to open the garage door, we want to have only thumb like this, like a like. Okay, so garage door opened. We make it so only thumb like. Okay, giving a like. Okay, so if the absolute value of self the landmark list in 4, 2, so we want only the thumb minus self the the landmark list in 0 and 2. Again, 0 is our home landmark, is greater than or equal to 100. Okay, that means it's like this. Get the same thing. The heights are self-dot underscore finger down. I probably should do something about that. If you want to write it down like 1,000 times like me, maybe we can functionize this. I'm not sure. Okay, so finger down, and we want the fingers equal, we want the rest of the fingers, okay? So we want 12, 16, 20, and 8 to be down, okay? So 12, 16, 20, and what was it? 12, 16, 20, and 8. Okay, now, if, again, the length of the set of H double equals 1, only one possibility, and that possibility should be true, then we know we're doing like a like. If we have that like, then print open garage door like this, okay? Same thing for closing the door. And the command that we're going to use is, oh, wait a minute, I got it wrong. Open garage door. Okay, we can do it. Yeah, I can do it. Okay, it's fine. Let's leave it like this. Spider-Man hand. Okay, so to close the garage door, we're going to do like this, like the Spider-Man hand. Okay, like this. Yep. So if apps, same thing of lm list of 8 and 2. Self right here, element list in 2 minus self that lm list in 0 and in 2 is more than 150. Okay, now careful here, okay, because we're looking for 2 fingers that are up, not down. Okay, if we just track the index, for example, like this, and we only track, hey, is middle, this finger right here, and the thumb down, and we don't care about this one, we might get confused with the index only. Okay, so in order to make it easier for Python to understand our landmarks, we're going to do and if our absolute value of landmark list in 20 and 2, which one is the 20 is the pinky. Okay, so 8 and 20 minus lm self dot lm list of 0 and 2 is greater than or equal to 135. It means we have like this, then h equals self dot underscore finger down, and the fingers that we want down are 12 and 60. Okay, we can also add the 4 just in case. Okay, cool. Now again, if the length of the set of h is 1 and h in the first place is 2, then we can print self-let command. We can print closing garage door. Okay, now those are all of the commands that we want to use. Okay, opening and closing the door, turning the lights on and off in garage and bedroom. Okay. Now, what happens if your light is on and you forgot your command and you turn the light on again? We don't want that to happen. Okay. Maybe in the lights you won't see it, but what happens if the garage door is closing and then you kind of send the command again to close? We are using a servo. Okay, so the servo tracks its rotation based on angles. Okay, so you'll make the servo rethink, so you kind of pause the garage and then kind of continue closing. Okay, we don't want that. Okay, we want to make sure that everything is smooth, so we'll make sure that all of the commands that we sent are unique. Okay, let me just close this down. There we go. So if self command is not equal to self the previous command, then self the previous command equals command and send the message to broker, which we're going to do later. Okay, I'll just leave it as a comment. But yeah, now you can see that we're not using the commands yet. Let's do that now. So bedroom light on makes self.command equal a string of bedroom light 1 for on. Okay, now same thing for bedroom light off. Instead of 1, it's a 0. Okay, now here instead of bedroom light, it's a garage light, so it's GL for garage light. Okay, now same thing for this part right here. If it's off, then it's a 0. Okay, now for the door, the command we're going to use is GD for garage door. In this case, it's open, so it should be 1. Okay, and same thing for this part right here. Instead of 1, because we're closing, which is off, it's 0. Okay, those are the commands that we're going to use. Okay, you can use the commands that you'd want as long as it makes sense to you. Okay, cool. Now, yep, that should be good. Okay, now we can test it. Should I test it now? I think, yeah, okay, let's test it. We have a little bug. We're going to solve it. It's easy to solve. Just I want you to see what happens if we don't use this. Okay, so are we outside of a loop? Yeah, no, it should be here. 1. There we go. Cool. So def main. Okay, inside of main we have self, and we have show equals true. Okay, because we want to show the hand. Okay, now we get the information of the capture. Okay, wait a minute. Let's see if that works. If I do this, I have to darts profile picture. What? Okay, I think I'm going to have a little bit of an issue because my camera is being used by Google. I don't know if that'll clash. I hope not. cv2 dot video capture 0. Okay. Now that means I want you to get the first camera that you get. In my case, I just have 1, which is my webcam. That's it. Okay. Cool. Now, while true, it means I want you to run as long as you want. Okay. We have success and frame. Okay. Equals capted read. Okay. Success is a variable of true or false that whenever a frame is not correctly parsed, then this one's false. Okay. Cool. So if success, or actually if not success, then break. Okay, we just got a bad frame. We don't want to deal with it, so break everything. Okay, we can pass, but just break. Okay, cool. So detect the landmarks. Okay, so we do frame equals self-did hand finder. Frame like this. Okay, now we update the landmark list, so we get self the position finder like this, using the frame that we give. Okay, and now print command if detected. Okay, so we do self the gesture command. Okay, nice. Now if show, it means if we want to draw our hand, then cv2.aim show and tracking. We want to show the frame. Okay, now just for OpenCV to close well, we have to do cv2.wait key 1, and the value it's 0x ff, which is the value in hex, which is word of q. So we want to check if basically q button has been pressed. Break. Okay, it means out. Cool. Now, in case we got out of here, sometimes the window doesn't destroy by itself. We have to say, hey, Mr. Window, destroy leftovers like this. Okay, so cap.release, and then cv2.destroy all windows like this. Okay, cool. So far so good. I hope it is. Okay, now if you don't know why do we use this, we use this function if dunder name double equals dunder main, means, hey, am I running all of this code from native Python? Okay, I'm not calling it from another Python. I'm running it directly in terminal. If yes, then tracker equals hand tracker. Okay, and then tracker.main. Okay, we call it. Now, this is going to have an issue. We don't have IoT control yet, so let's get rid of this. Get rid of IoT connection here. And yeah, I think that should be it. It shouldn't bug. Now, I hope it works, because StreamYard is using my camera. So I hope it doesn't clash. Let me just turn my camera off just in case. And let's see. I don't know why I have Siddharth's profile picture, but yeah. Okay. I can do pi. How did I call this? Camera, was it? Like this? Okay, let's hope it works. Okay, first. Okay, Tammy knows we have like usually 5 errors. Yesterday there were 3. I think I am betting I'll have 3 again. Okay, so chat, send on the chat the number of errors that you think I'll have. Okay, we have 1 so far. I think I'll have 3. Media pipeline solutions. In which one? Okay, by the way, when you see errors, don't run from them. Don't copy paste them into chat GPT. It doesn't do anything. Okay, you don't learn. Try to understand what's happening. So in this case, it says self.mp hands equals mp solution that has. Okay, Tammy says I'm going to have 3. I think so. Yeah, 3 is going to be the right number this time. We don't have solutions, so let me check my handbook and see solutions. Media pipe. Empty solutions had. Well, that's funny. Um, that's really funny. Media pipe has no attribute solutions. It should. Solutions. Is it written correctly? It's here. Solutions. Dot drawing utils. Media pipe. Yep. What is it that I'm missing? Wait a minute. What? Am I the NP? Did I? Is it all good? Let's see. Yeah, it should be all good. What? Yeah, it's written correctly. Solutions. Yeah, it should be good. Should I run it again? Maybe. Oh no. Is it camera? Yeah. Module media pipe has no attribute solutions. What? Okay, let's Google it real quick. Should work. No attribute solutions. There we go. Let's see, Gemini. What do you say? Typically, areas to several common configurations, issues. The most frequent cause to verify it got installed. Yeah. Oh, it said imported media pipe MP. Maybe reinstall media pipe. Maybe. Okay, I'm going to do something that's related to Tammy's suggestion. I'll do. Do you want me to print media pipe like this? Let me try to do something else. If I go back in my streams, I have another env here, so I can do deactivate. Maybe scripts activate. So I'm activating the env that I used before, the stream that worked. So cd IOT stream and then pi camera.pi. Well, that's weird. It's oh, yeah, we don't have reels. Okay. Yeah, it's weird. I think it's the MediaPipe version. Tammy is correct. I think I have to reinstall MediaPipe. I hope it works for everyone. If it doesn't, pip uninstall MediaPipe and then pip install MediaPipe. Okay. I'm just going to use this env just for time's sake. Okay, because we have 40 minutes. But yeah, it works. Tammy, you got it correctly. Okay. I think it didn't get installed correctly. Okay. Cool. Now. Okay, we have something that says reels. I meant release, but let's see. Second error. Okay. Let's see. Release like this. Okay. No, I'm expecting an error that says the camera is being used by Google Chrome. You can't use it. Let's we get support feedback. Okay, I don't know what this means. Inference manager requires more same signature. I think it's the one from the camera. If I turn it off. No. What happens if I don't give? Hello? Can y'all hear me? Yes. Okay. I just got rid of the camera permission for now. Let's see if it works. Okay, I don't know what. Oh yeah, there we go. Gesture command. Okay. Yeah, my camera will be off for a minute. Gesture and what's the one? Hand tracker doesn't have gesture command. In which 113? Okay, 113 should be here. My bad. Okay, try it again. 3, 2, 1. Okay, there. Wait key. Oh, that's the fifth. Okay, fifth error that I get. Wait key. Okay,
Isn't it weight key? Is it with capital key? K? Yeah, it's capital K. Okay, 6th error. You gotta have patience to program. What? Image did shape. Line 37. Really? Where is the error? 37. Is it image did shape like this? It's line 37. Let's see if I can find it real quick. No. Oh, yeah, that's true. It's height, width, and then I think it's FPS, the last value, okay? Which we're not going to use. That's why we put underscore. Okay, cool. So line 37, add an underscore to it. Okay. OpenTV's there. That's me. Yep. Hello. Oh, just don't look at my. Okay, there you go. So, okay. Light on. Light off. Pinky was. What was Pinky? Garage light on, off. Closing garage door, opening garage door, bedroom light on, bedroom light off. 2 was something, right? Garage light on. Pinky, garage light off. Can you see that? Open garage door, close garage door. We got it. Okay, just don't look at my clothes. Okay, I should have thought about that. Oh god. Okay, cool. Now that works. Okay. Thanks, Tammy. You're very kind. Thank you so much. It's nothing. Thank you. Cool. Okay, so let me just give it permissions to camera. Camera should be on. There we go. That's me. Okay, don't look at my room. Let's see. Should be virtual backgrounds. Virtual background, I said. What? Get it now? Okay, I don't have virtual background. I'm not sure why. Okay, so I'm sorry if you see at least blurring. Nothing? Okay, StreamYard will like, nope, you didn't use your camera. I won't give you blurry. Okay, cool. Let's live like that. Okay, cool. So, okay, now the solution to things was, I think it was a version of MediaPipe or MediaPipe wasn't called correctly. So what I used is, I used my environment that I created earlier today, which I know it was correct. Okay, you should. Do you have the same attribute solutions or solutions attribute error or not? If you do, uninstall MediaPipe and then reinstall it again. If that doesn't work, let me know. Okay, you have it. Oh, that's not good. Okay, someone else. Does someone else have it? By the way, are you using? Did you create your ENV? Did I create my ENV with 3.10? That's weird. Let's see if I can do something here. Real quick. I don't know if I can send you the actual version of the ENV. Should be this one. Okay, I'm going to do something that you usually don't have to do. Okay. I'll go into GitHub and I'll add a file. And then I'll add my ENV. Okay. It's here, it's here, all of the ENVs. Everything. Oh, no, wait a minute. How can I add the whole thing? Can I do like... Nope, it doesn't. I think it's too large. Okay, I'm going to do something that's weird, okay? I'm going to upload it here. Folder upload. Okay, it's uploaded. Okay, I'll send you the actual env that I used in my drive. Okay, just give it a second for it to upload. Okay. Cool. Okay, while it uploads, we can see that now the hand works. Okay, now we can have some gestures, which allows us to control stuff. Okay, cool. So the next thing that we have to do, we have 30 minutes. Okay, so we need this. Okay, IoT control, IoT connection. Okay, and let's make sure we are using the parent and using the it's inheritance. Okay, what's inheritance? Now, I'll just draw it in the meantime. Paint. Okay. So let's say that we have class number one. Class number one is four-legged animals. That's the name of the class. Okay. Or actually, something easier. Okay. Bottle. Okay, that's class number one. Now, class number two will inherit from class number one, but class number two is Coca-Cola. Class number three, which inherits from class number 1, 2, is Sprite. Yep. Both of them use bottles, right? Like this has a bottle, and this one has a bottle too, right? But each class is a different brand of drinks, of soda, okay? So even though all of them use bottles, Coca-Cola's bottle is not the same as Sprite's, okay? But we're inheriting the bottle. Same thing here, okay? We're going to inherit from IoT control. From IoT control, we're going to create something IoT connection. Okay. So class IoT connection like this. Okay. Where everything inside IoT connection can be imported into hand tracker without rewriting the whole thing. And that's where this super init comes in. Okay, cool. Now, before going into more detail, let's see if that, okay, nearly there. 11,000, we have 3,000. Okay, maybe I should, so it's easier for the computer. Let's see if I can do it. Nope. Streams, env. Can I compress this into a zip file? Okay. Let's give it some time, okay? In the meantime, is this one going to take long? Yeah, it's going to take long. No. I'll cancel this one. Everything in here out. Yeah. And then this should compress pretty fast. Okay, now we need to dive into MQTT and communication protocols, okay? We have one side of our app, which is the side that communicates, but we don't have a channel, right? And the other side will also expect stuff, but we don't have a channel, right? We need something to link both of them. We'll use the internet, of course, but we need MQTT, okay? So, give it 10 seconds. Come on, you can do it. Come on, you can do it. 5 seconds. There we go. Yeah, env is good. Okay, and now this one should go here. Okay, that should be pretty fast. Yeah, check that out, that's better. Okay, half of it. And then done. Okay, it's here. Share. Anyone with a link. Copy link, and here's the env that works. Okay, you unzip it, just put it in your folder. Okay, and activate it, and that should work. Okay, cool. So I'm not sure what the thing of media pipe is. Okay, nice. Okay, so we got it. Before diving into IoT control, let's go into our MQTT part. Opening Drive here. I need to go to stream. We did it to Python, and no, it's not Python. It's Arduinos. There we go. Cool. Now, MQTT and IoT. Okay, let's dive into this one. Okay, so what's MQTT? MQTT is a lightweight publish subscribe network protocol for machine-to-machine communication. Okay, it stands for message queuing, telemetry transport. Okay, as you can see here, we have one publisher, another publisher here. This is a subscriber and a subscriber. Okay, what's happening here? Okay, publishers speak, subscribers listen. Okay, for example, a publisher might be the code that checks the hands. Okay, so that's a publisher. A subscriber will be the servo that listens to the hand and reacts to the command that it's being sent. Okay, that's the subscriber publisher part. Okay, now we have some things that we have to understand. We have a broker, we have a publisher, a subscriber, and a topic. Okay, the broker is a server, basically. Okay, it receives all the messages and redistributes them to wherever they have to go. Okay, we have some examples. We have Mosquito and we have HiveMQ. Okay, we also have EMQX. Okay, that works. The publisher is the device or app that sends or publishes data to the blogger or a specific topic. Okay, the subscriber, again, is the one that listens. It's the device or app that receives, it subscribes to a topic and receives data from the topic of interest. Okay, for example, a topic is a string, it's a channel. Okay, of if you've ever used these walkie-talkies, okay, you have to be in the same frequency. If not, they cannot talk to each other, right? It's like you're talking in English and someone is speaking in, I don't know, Spanish maybe. So you can understand, right? So it's the same thing. We have to be in the same channel. So we have a channel dominated by a string. In this case, we have home/living room/temperature. That's a topic. Okay, you can all subscribe to this topic and you'll see that in the next stream. Okay, you can subscribe to this topic from anywhere around the world and send commands. Okay, what I do with this stream is I leave the electronics just stand by and you can open close them from your computer. Okay, it's really cool. Now, what is IoT? IoT stands for Internet of Things. It connects technologies to exchange data using internet. Okay, I'll give you an example. I think it's a Philips light bulb that connects to Alexa. Okay, so you can say, Alexa, turn my light on, or turn bedroom light on, so it turns the light on. You have also temperature sensors. You can have irrigation things like smart farming. You have retailing. There's an Amazon smart store that you can just go and grab things, and with a camera it automatically checks out for you. Okay, cool. Now, what's IoT used for, really? What do we use to use IoT? Okay, what technologies, what hardware do you use? I do love too, Tammy. I love IoT in farming. I think it's really cool because you can check all of your garden in one single app, and that app is being hosted by ESP32. So it's really cool. Okay, so if you dive into IoT farming, just let me know. Okay, I'd be really happy to help you out. Okay, so we have microcontrollers. It can be an Arduino Uno or an ESP32. Okay, specifically the Uno, because most of them, the new ones, have internet connection. Okay, if you buy an Arduino Mega, it doesn't have the connection. You have to by the receiver for it. Okay, cool. We have sensors, the temperature sensor, or like a proximity sensor. We can have a camera. We can have, I don't know, a Hall sensor, which is the sensor for magnetic fields. You have a bunch of different sensors, okay? And the actuators are the ones that are going to react with the sensor's data, okay? So we need LEDs, we can have relays or motors, okay? This is a very good thing that you were mentioning, Felipe. We're not going to use the actual hardware, okay? We're going to use a simulator for free that works exactly like real life, okay? The code is the same. The only thing that changes is that it's not real life, okay? If you copy paste the whole thing into a real Arduino, it should work the same, okay? Now, yep, again, here's the project. I'll explain that again in the second part of the stream. But just to answer to Felipe's question, I'm going to use WalkWe. Okay, we're going to dive into WalkWe in the second part of the stream. But just to answer the question, you can here select the board that you want to use. In my case, for example, I can go to my projects, and this is completely free. Like, it's free as long as, like, the perks of it is that you can use everything, but whenever you compile something, it takes time. Okay, and if the server is like there's a lot of traffic in the server, then you won't be able to compile it. Okay, that's the only bad thing. So you have to pay for premium, so to speak. Okay, but for example, I can go to this project right here. You can see here's the board, here's the code that should work the same as in real life. And I'm not sure, like, what does this do? No, this is MQTT2. Okay, I can run it, and everything that you see here, you'll see it in real life. Okay, so this is waiting for a connection of MQTT. We're not going to do that right now, but you see here we have a LED. We can change the colors. You have a cable here that connects to GND, which is ground. You have this other cable that connects to ESP2. Okay, so this is like real life, but not real. Okay, the other one that I like to use is shoot. It's Adobe. It's from Adobe. Shoot, what is this called? It's what was it? Emulator? No, what's it called? Shoot, I forgot. And I use it for streaming. Wait a minute. I should have it here. No, it's not CAD. It should be Arduino. Yep, Intro to Arduino. Here are all the codes that I use, but Tinkercad. There we go. If you go to Tinkercad, it's a different simulator. Okay. Yep. There we go. This is one that I used in like a couple of streams before. But see, here's an Arduino, and the code inside of the Arduino, you can either have blocks or you can have text. Okay, like this, right? So this is the code for it. Okay. Now it's not the code for this thing, but you can write your code here, and it works the same as in real life. You have sensors, you have motors, you have AC inputs or DC inputs actually. You have a board, you have lights. See that? So this is like a simulator of a car. You can see 2 motors, 2 sensors, 2 lights, and some relays here. Okay, but that's how you can start. That's the cheap way to start. Okay. Do you know what an SDK is? I tried. I tried it with Pico. 5-bit with SDK feels more complicated than the one I use in Arduino IDE. Okay, an SDK. Let's look for it. Oh, SDK. Okay, what do you mean by the SDK? Is software development kit? Yeah. Okay. Yep. Okay. I guess there's a SDK Pi Pico. I'm not sure. I've never used the SDK of the Pi before. Okay, let's see. Okay. All right. Okay. I've never used the SDK before in the Pis. I have a Raspberry Pi 4 or 5 here. I use it for a Minecraft server. But I've never used the SDK before. I use it as a Linux computer. Yeah, using CMake. Okay, I gotcha. And it's supported by IDs. Okay. Okay. I think I got how it works. What an SDK is. So let's go with step by step. The SDK is the software development kit. Is, let's say that it has all of the drivers and everything that you need to control your Raspberry Pi as a IoT board, or like an electronic board. Okay, so you can map your pins in and out. You can map your electricity. Okay, that's what the SDK does. Usually Raspberry Pi SDK is going to be more complicated because the Raspberry Pi is a computer and an Arduino is a microcontroller. Okay, a Raspberry Pi has way more things. Okay, I suggest you read this. I've never used the SDK before. I use it as a Linux machine, and that has worked for me, at least for whatever I needed. I'm not sure what you need it for, but try reading that. But yeah, again, Raspberry Pis are way more complicated than Arduinos because they're computers. Okay, cool. Okay, that's a good question though. Nice. Okay, so I'll see you in 2 hours. Okay, I can't speak anymore. My throat is super sore. But yeah, I'll see you for the IoT communication and electronics part in 2 hours. Okay. Before that, please, as always, if you could give me feedback. Okay, I need feedback. I love feedback. Okay. So if you click on that link, you'll see something like this. Click on continue. You can type part 1, and you'll find building a very smart IoT helper part 1. 1 for I didn't like it, 5 or like 10 for I did like it. I don't take anything personal. It helps me grow. Okay. Tammy says, "Hey Bully, great to see you. It's midnight here, but gonna watch your second stream recorded." Awesome. Thanks, Tammy, for watching. Go sleep. I hope that tomorrow is going to be a good day for you. Thank you for watching all of my streams and for being here. But yeah, so please give me feedback. And yes, the next streamer is Kari with your first machine learning model part 3. That sounds really interesting. And yeah, go give Carrie some love. And yeah, I'll see you in 2 hours. Okay, just after Carrie's stream. Okay, I'm going to get some water, get some rest, and probably some honey for the throat. But yeah, thank you so much for watching. If you have any questions, just ask me on Discord. I'm on Discord with Bully 1601. Okay. Cool. Thank you so much. I'll zoom in. There we go. I'll zoom in here. Don't look at this. Thank you so much for watching, and I'll see you in 2 hours. Okay. Bye bye.